Hello everyone, welcome to the e-learning modules for Underhood thermal application using SimLab as a preprocessor and AcuSolve as a solver. These e-learning modules will demonstrate the workflow for Underhood thermal application. We will run a CFD simulation on a simplified geometry of a combustion engine inside a canopy. There are louvers surrounding the canopy, allowing air as a working fluid to circulate in and out. A fan with a shroud layout, rotating at 1500 RPM, is going to be the main driving force for the flow field. There are two radiators at the front and back of the canopy to cool the engine. Heat is transferred from the coolant to the surrounding air, increasing the ambient temperature inside the canopy. Engine will have thermal battery conditions applied on the exhaust manifold, the fin on the top, and the engine blocks. Notably, we will also model the air intake and the exhaust of the engine. These e-learning modules will be divided into 4 videos. The first one is going to be for preparing non-wrapped parts, where we need to resolve the small imperfections on the CAD level and surface mesh the canopy. The second one is where SimLab wrappers is introduced, inspection process and other alternative way to fix imperfections are also outlined. Boolean operation on the surface mesh level will be used in this video to increase the resolution at important phases. We will connect to surface mesh bodies, place volume mesh controls, and CFD mesh the model in the third video. In the fourth and final videos, I will set up the flow domain, the heat exchangers, and the moving reference frame. After running the solver, I will post-process the result from AcuSolve. Now let's get started with our workflow with the non-wrapped parts preparation step. Opening up SimLab, I will start by importing the geometry. Make sure that we have solid, sheet, and then connected body enabled. There's 2 parts in this CAD file. We have the canopy, which is what we will be working on in this video. And we have the engine, which is saved for the next video. Now let's hide the engine. I will hide the outside part so that we have a better visualize inside. So here is our heat exchangers, the large one and then the small one. We'll keep it right there. And there is our fan. For the fan, I will move it into the separate part for easier operation on the canopy. Move to root model. Now the fan should be in the separate part. If I enable the section cut, you see that the fuel tanks, the 2 fuel tanks are not quite touching the chassis. So we're going to move it a little bit down. And we need to move the rail and 2 tanks. We snap it into the bottom surface. And if we enable the section cut again, they should be touching. And on the lateral side of the tank, we see the tank not quite touching the chassis surface. So we're gonna move the tanks again. We click on the part you want to move, fix the direction, and then snap it into this surface. And then we're gonna do the same for the other tank too. Fix it on one direction and snap it into this surface. So they are touching, which is great. If we pay attention closely, the four surfaces of the rail is also not quite touch the surfaces. So we can extend it a little bit further. We can hide this surface. We select the move tool and then select four surfaces. We click and then we're gonna snap it into a vertex. This is gonna be this one right here. So it's about 7 millimeters. Click update to apply changes. So if we create a section cut on the X normal direction, and then move it a little bit, so the rail should touch the surface of the chassis. Let's hide this. We also need to fix the small heat exchangers because there is a gap between the shroud and the heat exchangers. So we're gonna move it a little bit backward and then extend 4 lateral sides. This is enough, it doesn't have to be accurate. And then we're gonna extend 4 lateral surfaces. Snap it into this surface of the shroud. I might need to hide this so that it doesn't obstruct the view. One last surface. Okay. Before booleaning everything together, I'll start by placing mesh controls on the accessory part. I will start with placing two mesh controls on the heat exchangers. Just isolate. Mesh and mesh controls. Place phase mesh control to heat exchangers. Seven millimeters. Put this to 25. And the shroud, because we need a lot of flow definition between the shroud and the fan, so I'll also place surface mesh control in this region. Let this 15 degree. Okay. Now I can boolean everything together by going to geometry and connect. Windows select everything. The input going to be cat, the operation going to be combine, and we need to create connected bodies. So if you notice, the smaller shroud and smaller heat exchangers and the tank, another tank here, they are not connected to anything. So it's why it becomes separate part. No problem. We can start surface mesh. I'll choose the average element size of 15 millimeters. The maximum angle per element I will choose 25. Because we already do the Boolean operation, we don't need to create matching mesh. Just keep it visible. Click OK to start the meshing process. When the meshing is done, we can grab this body and then unmerge it. We also need to unmerge the small heat exchangers here too. We have finer mesh control at the shroud surfaces. Take these two heat exchangers and move it into another part group. Let's hide it. Now we're gonna merge all of these again, except the 2 heat exchangers. Now let's flatten the model. So the canopy has been done. Now we need to resolve the moving reference frame, the rotating region. We need to get the shroud back. Let's unmerge this. Hide this so that we have better visual. We're gonna create the MRF domain so that its diameter is exactly in the middle of this clearance. I'm gonna create a cylinder. In the definition, I will use the circular edges. Let's hide the radiator. Need to adjust the diameter so that is right in the middle. Need to enable the engine so that we can adjust the axial dimension, and it is not touching the engine like this. Click apply. And let's hide these faces. We can move the axial a little bit more. I think that's enough. And let's hide the shroud right here. You need to make sure that the MRF region is not touching these big heat exchangers. Maybe we can get a bit shorter. This is good. Now let's hide the canopy and the engine. Now we need to Boolean the MRF and the fan together. Now do Boolean subtract. The target body is gonna be the cylinder region, and the tools body is gonna be the fan. I'll keep the tools. Click OK. This is our rotating region. Now I'll play some mesh control on this region. I'll place fine mesh control on the leading edges of the fan. Right click and select identical faces. Make sure that all of the fan plates are selected. Leading edges. This is going to be 1.5 millimeters. I'll put that as 15 degree. Click OK. For the other fan surfaces, I will choose the mesh control of 5 millimeters. I'll right click to get my old selection, and then I hide it. And then here I just simply window select all of the faces and apply mesh control. This can be 15 degree, like the leading edges. Click OK. For the surrounding, I will choose the mesh size of 7 millimeters, the same mesh size of the shroud. Choose this at 15 degree. Click OK. Let's surface mesh this. Because all of the surfaces in this body already defined with the surface mesh control, so regardless of whatever I put here, all of my mesh control will be respected. When the meshing is done, we will rename this into MRF region. Let's take a look at the mesh size. So we have finer mesh control at the leading edges. Okay, everything is good. At the end, we will have the frame with our MRF region. The same mesh size apply on the shroud and the MRF interface. We also have the surface mesh of the big radiator here, and also the small radiator. The surrounding element is 15 millimeters, and then there is surface mesh control on the small heat exchangers of 7 millimeters. Now we save our database. And let's move to the engine in the next video.